Hey, good morning, everybody. So, as you can tell from class, theme of the day is learning how to solve a percent yield and a limiting reactant type problem. This lab that we're going to look at is really good in the fact that it incorporates everything we've done so far in the chapter. All right. If you're taking a look up here, what you're going to see is that we've got two goals to accomplish. Goal one, we want to create, isolate, and collect a sample of calcium carbonate. All right? And the reason we're able to do that is because calcium carbonate is a solid that doesn't dissolve in water. All right? Now that we know that's what we're supposed to be creating, that means we can calculate how much of it we're supposed to get, theoretical yield, and then we can go into the lab and actually conduct the experiment and measure how much we really got, our actual yield. And once you know your actual and theoretical yields, you guys can get a percent yield. All right, so I said we're going to create it, isolate it, and collect it. How are we going to do that? All right, well, the first thing we're going to do, all right, is we're going to initiate a reaction that creates the calcium carbonate. What we're going to do is take calcium chloride, and we're going to react it with sodium carbonate. Now, both of these substances are a solid back in the lab, but I'm going to dissolve them in water to let them interact with each other better. Right? And both substances are what we call soluble. They can dissolve in water. Right? If you look at this, you'd right away identify that it's a compound plus a compound. That makes it a double replacement. Right? So the calcium and the sodium trade places. So we get calcium carbonate and we get sodium chloride. All right, if we wrote and balanced an equation for that, like we always do, you'd see we get the CaCl2 plus Na2CO3. Right? And I'm just crossing and reducing charges across the board here. CaCO3 and NaCO. Right? And then we'd have to balance that thing. 2 NAs, 1 Na. Put a 2 there. And that takes care of my CO. All right, now the part that you guys are less familiar with. All right, the CaCl2, we are going to make what we call aqueous. We're going to take a solid, we're going to dissolve it in water. The Na2CO3 is going to be aqueous. Take a solid, dissolve it in water. We're going to mix those two things together. And luckily for us, calcium carbonate is what we call insoluble. That means it's going to form a precipitate. It's going to fall out of the liquid as a solid in the beaker. So inside your beaker, it's going to look snowy. It's going to show some type of indicator that you're getting a solid formation. And the NaCl is aqueous. All right, so in terms of like the physical setup in the lab, that's how we're going to create the CaCO3. Now we need to isolate it. All right, so what we're going to do is we're going to take a beaker that has the CaCl2 in it. We're going to take a separate beaker that's got the Na2CO3 in it. We're going to dump those together into a third. Now, when I get that third beaker, I'm going to create the solid CaCO3, and then I'm going to have aqueous NaCl, which means that's floating around as ions, and then I'm going to have any leftover excess. And one of the things that we're going to do in this lab is we are going to vary the amounts of the CaCl2 and Na2CO3 to see if things turn out different based on who runs out first, our limiting reactant. So the two amounts that we're going to try in the lab, first we're going to try, just let me check to be sure. 0.75 and 0.75. for trial 1. That's the one I'll do with you guys. And then we're going to make it so that there's a lot more CaCl2 than Na2CO3. And we want to see, if we do this, what happens if we change who our limiting reactant is. So either way, we're going to have a leftover unreacted reactants. Moral of the story is we have to isolate that CaCO3 solid. So what we're going to do is we're going to take what's in our beaker and we are going to dump it through a filtration system. Right? Our filtration system is going to have a piece of filter paper that we will have weighed ahead of time so we knew what it was empty. Right? We're going to wet it. We're going to put it inside of a funnel. Right? We're going to put it through our ring stand, and then we're going to pour our substance through. And because of all the things in there, the only one that's a solid is CaCO3. It is going to get stuck in the filter, where the rest of the stuff, the NaCl, and any leftovers are going to fall through into what we call the filtrate solution. All right, but the moral of the story is the CaCO3 is going to stay stuck in the filter. So what we can do is get a piece of filter paper that's got CaCO3 on it, but it's going to be wet from all that liquid that went through it. So what we need to do is we need to get rid of the water. And to do that, it's no big deal. We're just going to put it into an oven in the back, and we are going to evaporate out the water, leaving behind just the filter paper with the CaCO3. So like many experiments, one of the first things we're going to do is mask the filter paper all by itself. All right, now we have the filter paper, and then at the end, if we do things right, we'll have the filter paper with the calcium carbonate. You just isolated the calcium carbonate, and now we can gather it and get a mask on our filter paper. All right, so that's the idea behind the lab. So let me take you back there, show you what's going to happen. And well, you're off. This is one of the few labs that pretty much everything we're working with is fairly harmless. So today, if you had been in person, you would see we don't need to wear goggles. All right, so if you guys take a look, there's two things attached to the video that you're watching. All right, one is the packet describing the experiment. I just walked you through all of the pre-lab stuff. We are going to go through the procedure together to gather our data for our data table. All right, I'm going to give you guys this top line as we go through this video. I'm going to repeat the process with the 1 gram and the 0.5 grams, but you don't need to watch that part. I'm going to simply send you a picture of what the data for the second part of the experiment is going to be. All right, then you've got your post-lab questions. And on the very back page, you've got your lab format. All right, so this is a handwritten one. All right, all you need is a title, a purpose, materials. Don't worry about the procedure. It's in the packet. Fill out your data table in the packet. Answer your post labs in the packet, and then a 5-part conclusion on a separate sheet. So it's a title, a purpose, materials, and a 5-part conclusion on a separate piece of paper. That would get stapled to the packet where the rest of the things would be. Those of you guys that are full-time at home, you guys would simply send me images with the title, the purpose, the materials, and the 5-part conclusion. And then you'd send me pictures of your data table and your post-lab questions filled out so I could check. All right, so first thing it tells us to do is to get 0.75 grams of each of these substances. All right, so in one of these, we've got the Na2CO3, really fine white powder. In the other, we've got solid CaCl2. Both white solids, but definitely different. The CaCl2, all right, is more like Dippin' Dots. and the Na2CO3 much tinier. So the first thing I'm going to do is get 0.75 grams of each of it, using my scoopula and using an empty weighing dish here on the balance. So I'm going to put the weighing dish on the balance, and I'm going to zero it out because I don't want the mass of the dish. And then I'm going to transfer 0.75 grams. And this isn't one of those times where we want to just be near the amount, right? Because we can take a subtraction to get it. I wrote in your data table 0.75, so we need that to be the exact amount. All right, so there's the 0.75 of the Na2CO3. Then we're going to take another dish, put it up here, zero it out, and we're going to get 0.75 grams of our calcium carbonate. Okay, overshot just a bit. All right, so that's 0.68. And 0.75. All right, so that's going to go into my bigger dish. Now it tells me to take 30 milliliters of water and dissolve each of these substances. So I'm going to use my grad cylinder. And the amount of water doesn't really matter because we're just dissolving it. But the more water that you use, the more you're going to have to filter off when we get to the point that we're filtering. So, I mean, I could really dissolve it up in an immense amount of water, and it doesn't really affect the outcome too much, other than it's going to take me forever to filter. All right, so I'm going into my drawer. I'm going to grab my glass stirrup. All right, and all I'm doing is getting this solid to dissolve. And it tells us that we need to do that for about 4 minutes. So what would happen is you would be dissolving one, and your partner would be dissolving the other. Right? But you guys are stuck with just me, so it's going to take an extra minute for me to get both dissolved. Okay, so my sodium carbonate is fairly dissolved. Now, time to go to work on my calcium chloride. And one thing that might help is if you break up the calcium chloride at the bottom, it tends to dissolve better because you're increasing its surface area. And when you break it up to make it more like powder instead of those Dippin' Dot looking things, the water can attack it from more places. All right, so if you take a look, here's my calcium carbonate. Nice and dissolved. Still a little bit of solid there in my sodium compound. So got to stir just a little bit more here on my sodium compound. Take a look. There's my sodium carbonate dissolved. So what I'm going to do is I'm going to take both of these guys and I am going to pour them into this 100 ml beaker. And so nothing crazy happening there. I just dumped that over. But when I pour this one, it should initiate the reaction. Okay, and sure enough, you guys are seeing that is absolutely not the same as it used to be. All right, so I'm going to stir this guy. And all I'm doing here is making sure I'm giving the calcium chloride time to react with the sodium carbonate. All right, so I'm going to stir. In your packet, it says you should stir this for about actually, it doesn't give you time, so I usually just add that part and I say stir it, all right, for about 2 minutes. All right, so this white milky looking stuff is actually calcium carbonate that's got all that other stuff mixed in with it. So we need to isolate this. All right, so like I said, to isolate it, we're going to set up a filtration system. So I'm taking my ring stand with my iron ring. I'm going to go into my drawer. And I'm going to do 2 things. I am going to get out my pipe stem triangle, which will hold my funnel, and my funnel. And all this is so that I can keep my hands free. And then I'll just take the 250 ml beaker that I had before, putting it under it. All right. Now, when we start to filter this, the idea is that we don't want any of the white stuff to go through the filter paper. All right. Otherwise, we know we're losing the product that we want. So we want our filtrate to be clear and colorless because our leftover reactants were clear and colorless, and the sodium chloride, salt water, is clear and colorless at the amounts that we're using. All right, so what I'm going to do is I'm going to go get a piece of filter paper. Okay, and in your data table, it wants us to get the mass of that filter paper right there. All right, and the reason is at the end of the day, like, I need to know what this guy weighs by itself because when I get my calcium carbonate on it, I'm going to need it. All right, so what I'm going to do is I'm simply going to fold this in half twice. That's 1, to set up how it's going to be when it filters. And 2, it just fits onto the balance better to make sure none of the paper's hanging off the edge. All right, so I zero out my balance. I put on my filter paper. All right, the filter paper weighs 0.50 grams. So right here for your massive filter paper, that's a 0.50 gram. Now what I'm going to do is I'm going to take that filter paper, and there's a couple filtering windows. All right, there's top window, that's a good filtering window. Middle window, that's a bad filtering window because it's got that big open space over here. And your bottom window, and that's another good filtering window. All right, so to help it stick to the funnel, all I'm going to do is run a little bit of water through it. And like I said, I don't really care that that happened because the whole idea is I'm going to eventually put it in the oven. And when I put it in the oven, I am going to evaporate off any of that water that was there. So I go to one of my filtering windows and I put it inside my funnel. All right, and now we get to the tedious part of the process. I'm going to pour this liquid in here. And I need to make sure that it stays below the filter paper, because if it goes behind it, that means white solid is going to drip down into our beaker below. So a good thing to do while this portion of the experiment is going on is to jump to your post lab. And based on the amounts that we did, you were able to write and balance the chemical equation. You're able to predict the theoretical mass of calcium carbonate because you can do your side-by-side bracket problems for trial 1 and trial 2. Number 2 here is going to propose 4 answers, and the 2 smaller ones is how much white solid we're supposed to gather. You'll be able to say who limits, right? Remember, look at who gets the smaller number. If you trace it back to the beginning, That's who's supposed to limit you. All right. You can answer number 4. It says in steps 1 and 2, it allows you to add more water to dissolve. Will it add extra? Will it affect the overall results? We talked about that, right? Not going to affect the results because we're filtering it off. Right? In 5, they ask us about what aqueous is. Go back to the beginning of the video and you'll see what an aqueous is. All right? It's not until number 6 that we need our final results for 6, all right, to get your percent yield. All right, so all of this, like I said, just takes a little bit of time. So we'll pour it and see we're doing good. We had, all right, about 60 milliliters in here to start, and we're already under the 40 mark. It just takes a little bit of time for that substance, all right, to drip through. All right, so I'll be filtering for a minute. All right, now grab a cup of coffee here while you guys can work on those problems. And as soon as it's done filtering, we'll get that guy in the oven. What I'm doing now is I'm bringing around a pipette, and the whole idea is when we get close to the bottom here, you're going to see some of that white solid is going to stick to the glass. So the pipette is there to help rinse any of that solid off the glass to try to make sure that we're able to get as much of the product into the filter as we can. Okay, so again, this is like the long portion of the lab. And so I'm just going to keep on filtering while you guys work on problems. And one of the tips that I try to give is before you pour, give it a little swirl, and that helps it not stick to the glass as much. As you can see, we're chipping away. My liquid underneath is still clear and colorless, which is good, which means we haven't missed anything during the filtration process. Otherwise, it can be a bit of a pain. You'd have to pour all that liquid back up through to ensure you got your maximum yield. It's really down to the last of it here. Pouring that in. Trying to get as much of that solid in. But like I said, inevitably, you get a little coating that we're going to use a pipette to help rinse down the side. So the 40 mils isn't the whole story. I will have to get just a little bit more, because when I rinse that guy down the side, you're going to find out there's some good stuff in there that we want to filter. Right? And you would just do that once or twice. And if when you use your pipette to try to rinse down the sides, you look, and it's still pretty clear and colorless, right? That means you've gathered all the solid that you're going to be able to get. All right, now, one last little time where we have to wait. Once this filter's off, what I'm going to do is I'm going to go into my drawer and I'm going to get one of those circular watch glasses out. Right in every drawer has them. It looks like this. All right. And I'll just give it a quick wipe off just so that nothing on the watch glass gets stuck to our filter paper. But once the filter seemingly has all the liquid through it, I'm going to open that guy up and I'm going to put him on here. And like I said, we need to take him back to the oven to dry that guy. All right. And while we're waiting for that to filter, I'm just going to show you what the oven setup looks like because we have a minute. All right. So if we come back here, you guys look into my fume hood. All right. Here's the oven. All right. And it's on. And usually what I'll do in class is I'll put these in waves. Right? But you open it up, you can see there's just shelves. I'm not going to leave it open too long. Don't want too much heat to escape. Right. But we'll put our watch glass on one of those balances. I'm sorry, one of those shelves. And when we do that, usually about 8 to 10 minutes in there is enough to evaporate out any of the water that is there, getting us back to the filter paper, which we had at the beginning, but now there'll be some white solid on it. All right, so it looks like it's got just a couple more minutes till we get to that point, and then we'll get it back in the oven. so looking like we're pretty much there. Sometimes you can give it a tap just to help it along. And this process is called gravity filtration because I'm not using any type of like aspirating system, which would be one where like I'm creating pressure differences and it's like forcing the liquid down through. That's why this one takes just a little bit longer. But on the whole, it would have been excessive to set up the whole filtration. And a lot of times you end up taking some solid with you, which we don't need to. All right, so the next part, you'd go in your drawer, and you're gonna want to get your forceps out, get your tweezers. And if you take a look down in the funnel, all right, some white solid in there, and it pulls up just a little, but like I said, that is going to dry when we put it in the oven. So the key to this part is opening it up so that it is facing the seal. Okay. And if I do that, this is what you're looking at. All right, so I'm going to take that into the bag, and I'm going to put it in the oven. Hey Siri, set a timer for 8 minutes. Okay, now I'm not going to make you guys wait through that portion. What I will do is after the 8 minutes goes by, I will go back. Right, I will bring it up here. I'll get the mass of it, and like before, I'll send you a picture of the filter paper with the calcium carbonate on the balance. Right, I will also send you a picture of trial 2, right, where I would have been taking the 0.5 and the 1.0 instead, doing the same process and getting you the same results. All right, so I'm going to clean up here, just for a second. And like I said, I promise I will be sending you guys info soon. And if you're having any questions, please reach out, and I should be checking in your breakout rooms momentarily.